Welcome to Lesson 1.3 Learning Paradigms. This section introduces the three main ways machines learn, and these are the foundations of modern AI systems, and understanding them is essential for anyone pursuing a career in the field. By the end of this lesson, you will be able to define the three main learning paradigms in AI, explain how they differ, identify their key tasks, connect each paradigm to everyday examples, and understand how they combine in modern AI systems. So, learning paradigms. Machine learning is built around three major paradigms. The first is supervised learning, where models learn from labeled data. The second is unsupervised learning, where models find hidden structure or patterns in unlabeled data. And the third is reinforcement learning, where an agent learns by trial, error, and feedback. The system receives rewards for good actions and penalties for bad actions. Together, these three paradigms define most of the ways machines learn and adapt, and you'll see examples of each in real world systems. So, what is supervised learning? Supervised learning is where models train on labeled data, where each input is paired with the correct output. The system uses these examples to learn a mapping from inputs to outputs, then applies that knowledge to predict outcomes for new, unseen data. There are two main tasks in supervised learning. The first is classification, where the model predicts discrete categories such as spam or not spam, and the second is regression, where the model predicts continuous numerical values such as a house price or tomorrow's temperature. Supervised learning is the most widely used paradigm because it directly learns from past examples to make accurate predictions in the future. Supervised learning powers many applications you use every day. Email systems rely on classification to detect spam messages. Banks apply classification models to assess fraud risk or determine credit scores. Regression models are used by real estate firms to forecast housing prices, and they're also used by financial analysts to predict stock values. Even voice assistants like Siri or Alexa depend on supervised learning, where labeled audio data trains models to recognize spoken commands and map them to the right actions. Now, what is unsupervised learning? Unsupervised learning works without labels. The model receives only the raw data with no predefined answers and must discover hidden structure or patterns on its own. Two core techniques are especially important: clustering, which groups similar items together, such as customers with similar buying habits, and then second is dimensionality reduction, which simplifies complex data sets by reducing the number of variables while preserving essential patterns. Dimensionality reduction is especially valuable for visualization, data compression, and noise reduction. These methods are often used for exploration, anomaly detection, or to prepare data for further analysis. Examples of unsupervised learning include segmenting customers into groups for targeted marketing campaigns, detecting unusual financial transactions that may signal fraud, or automatically grouping photos of the same person in your smartphone library. In natural language processing, unsupervised methods are used to uncover hidden topics in large collections of documents, helping researchers and analysts make sense of massive amounts of unstructured data. Now, what is reinforcement learning? Reinforcement learning is a paradigm where an agent interacts with an environment, The agent takes action, observes the results, and receives feedback in the form of rewards or good actions or penalties for bad actions. Over time, the agent adjusts its strategy, known as a policy, to maximize its cumulative reward. Unlike supervised learning, which provides the correct answer for each training example, reinforcement learning provides only feedback signals, making the learning process more exploratory. The objective is not just immediate success, but maximizing long-term rewards across many steps. This approach has produced some of AI's most famous achievements. Reinforcement learning trained AlphaGo to defeat world champions in the game of Go, an accomplishment once thought impossible for machines. It powers self-driving cars, enabling them to navigate safely by continuously adjusting decisions based on feedback from the environment. It also teaches robots to walk, grasp objects, or adapt to unfamiliar settings. Online platforms apply reinforcement learning to optimize recommendations, showing users content that maximizes engagement over time. These examples highlight the trial and error nature of reinforcement learning and its focus on long-term success. So, these paradigms appear daily. Supervised learning runs your spam filter, unsupervised learning organizes your photo albums, and reinforcement learning guides GPS apps that reroute based on saved time. Modern AI often combines all three. Congratulations! We've now completed Lesson 1.3 Learning Paradigms. You should be confident in distinguishing between supervised, unsupervised, and reinforcement learning and in recognizing their common applications. Remember, these core ideas are very important. Supervised learning means learning with answers. Unsupervised learning means finding patterns without answers. And reinforcement learning means learning by trial and error with feedback. Take a moment to review your notes, and when you're ready, we'll move forward to the next lesson.